Our next speaker in this room is Jenny Shen, who will be demystifying the Ruby package ecosystem for us. Jenny is a senior developer at Shopify. She's based in Toronto, Canada. As a RubyGems.org maintainer, she works to help secure Ruby's dependency ecosystem and is passionate about open source. Jenny is also one of the most energetic, enthusiastic, and smart people that I know, so it's my pleasure to invite her on stage.
Thanks for those amazing words, Ufuk. Before this talk, Ufuk asked me if the intro was good, and I was like, oh yeah, it's good, but feel free to add how great I am. But he actually did, and it was very sincere, so thank you. Yeah, hello, San Diego. Welcome. I hope everyone's having a great time at RubyConf so far. I'm certainly having a blast here with this great summer weather. It feels like an absolute treat compared to the dreary Canadian weather. If you spoke to me during this conf, I probably have mentioned the weather to you, and I completely sound like a broken record at this point. But I can't help it. From the Indeed editorial team, they say that a simple question like, how about the weather we're having can be the start of friendship and connection. And that's what some of us are here for, including myself. And funny enough, right after I put this into my talk, I met someone from Indeed, so the stars aligned. Furthermore, from social self, it is not number 1, not number 2, not even number 3, but number 4 on the top 8 small talk topics to chat about. It says the weather is a safe topic, so completely fail-proof and for me to leverage. And bonus, if it goes well, it can transition to more interesting topics, which what can be more interesting than talking about the weather? If you're catching my drift, we can say what that topic is together. And hint, it's the title of my talk, Demystifying the Ruby package ecosystem. Wonderful. Okay, back to business. Hopefully you're excited in learning a bit more about the foundation of what Ruby projects are made from, gems. And if you're not excited, I don't know, go chat with someone about the weather. So to get us started, raise your hand if you ever ran bundle install. Okay, seems like a lot of you have. Then you've probably seen a long list of gems being fetched, installed, or being used on your machine. And if you're running bundle install in your Ruby project, you can boot it up, run the test, and it's working all fine. Yay. You can go right to coding that new feature that would amaze its users. But do you really know what's going on when you run bundle install? How can you use gems so easily in your Ruby application? These are questions that I was personally wondering about and wanted to get to the bottom of. Great opportunity for some talk-driven development. So hopefully by the end of this talk, you'll also get a better understanding of the ins and outs of Ruby dependencies and how they work in our Ruby applications. I'm Jenny. I work at Shopify under the Ruby and Rails infrastructure team. I've been mostly focused in working in RubyGems.org in the past couple of years to help add security features and policies to help make our dependency ecosystem more secure, which I'll touch upon later in this talk. RubyGems.org is the community's gem hosting service that hosts over 190,000 gems. It is indeed a Rails app where you can view the gems available and the information about each one of them. And it provides an API to manage gems. The tool to manage these gems is RubyGems without the org. It is a package manager. It is bundled with Ruby and is used to manage gems using the gem command. Bundler is also a gem that gets mentioned a lot with RubyGems. Its main purpose is to help resolve and standardize the gems used in a Ruby project across all machines and environments so they all work together well. Fun fact that Bundler and RubyGems lives in the same GitHub repo but gets released separately. So today we'll go through how gem installation works under the hood. We'll first go through how gem install works in installing a single gem. Then we'll go through how Bundler goes and tackles installing the correct dependencies for your Ruby application. After that, we'll see how dependencies work so seamlessly in a type of Ruby project, which is Rails. We'll be touching more about dependency groups, bin stubs, and debugging a gem in a Rails application. And during the last few minutes, I'll share some evil things that could happen when installing gems. If people want a copy of the slides or also some resources, feel free to scan this code. I'll also have this up at the end of my talk, so if you miss it now, it's totally fine. Cool. So how does gem install work? What happens when you run gem install Rails? When you run it, it shows that it installed the most recent version of Rails and its dependencies, but what's actually happening? When the command is run, it'll accept a gem name like Rails and its version requirements. This could be an actual version, version range, or by default, it'll specify lower bound. Each command that RubyGems supports has a corresponding file in the commands directory with an execute method. The name and the version that gets passed into the command will go through the install gem method. From there, the version will be parsed into a requirement object. This is where if you specify an invalid requirement format, RubyGems will yell at you and throw an error. It'll also initialize a dependency installer, which is responsible for installing a gem along with its dependencies. By calling resolve dependencies on the dependency installer with the name and version, it'll return something called a request set. A request set represents a list of gem information or activation requests needed to determine how to download and install the gem. In resolve dependencies, it parses the gem name and the version into an actual dependency object. Then a request set will be initialized, and the dependency will be parsed into a set and resolved when called some resolve. Within resolve, it determines which versions of the dependencies should be installed. This will return a request set with activation requests, which again represents the gems that need to be downloaded and resolved. RubyGems currently uses the Millennial resolver to create a dependency graph to determine which versions of each dependencies will work with other gems. The TLDR of this algorithm is that given a gem, it'll fetch all of the possibilities available to install based on the requirement. It'll choose the best requirement or the most recent one, and we'll add it to the current state of the dependency graph. Then it will find the possibilities of its dependencies, as you can see here. If there comes a time where there's no possibilities present, we will rewind to a state where the conflict can be resolved or avoided, yes, and select the next best version, which is the next latest. To find version information, the fetcher will receive specs of Rails from the index, which is just a separate instance of RubyGems.org to serve this information, and we'll parse each line with the version and platform at the front, the dependencies of the gem in the middle, and the requirements at the end. So we're back at the top level of the install command. We now have a request set returned from resolve dependencies. It's time to actually download the gem by calling install on the request set. So in install, we're concurrently downloading all the gems from the remote that aren't cached on the machine from the RubyGems.org S3 bucket. And each gem is stored as a .gemfile with the gem name and version as the file name. When a gem maintainer wants to publish a new version of a gem, they would run rake release with the gem spec if they have the bundler gem tasks included. And rake release does two things, gem build and gem push. Gem build will take the gem spec of the gem going to be published, create a tarball file with the .gem extension. And gem push takes in the .gem file and posts it to the RubyGems.org creation endpoint with the .gem binary. If all the things are good, like if the user has the correct permissions, the file will be written to the S3 bucket. If we actually download the gems from RubyGems.org, we get the .gem file here. We can untar it, and we get a folder with more compressed files. The checksums provide hash values for other files to act as a signal that the files have not been tampered or corrupted with. And we also store a compressed file of the metadata. The data contains the actual gem contents, like the executables included and the libraries. And you can actually run gem unpack with the gem name, and you can easily view the gem contents of a specific gem. So for example, like active support, once you run unpack, it'll create a folder in the directory with the contents of the gem. Once it receives the binary from the S3 bucket, it'll untar the file and store the data on your machine under the gems folder of the specific Ruby. It'll store the .gem file in the cache in case you need to reinstall it at any time, and the gem spec in the specifications folder. It also installs the executable specified in the spec under the bin directory, so you can run executables easily, like bundle install, Rails new, and those kinds of commands. And to use the gem in your Ruby project, you can require the library using require. This will add the gem path to the load path variable in Ruby so Ruby can use its code. So for example, if we pull up in IRB, we can't call active supports method blank on, is it RubyConf 2023 amazing, without first requiring it. After we require it, we can see that active supports gem path is now included into the load path variable. Right there. Oops. So yeah, that's kind of gem install in a nutshell. It's a lot more complex than that, but that's a brief overview. Cool, right? So now that we went through how to install gems using the gem command, how does bundle install work? As I said before, Bundler makes sure that, that gems in a Ruby application stays consistent among all machines, and it does that through defining a gem file in a project. When bundle install is run, Bundler will build a definition object which represents the information in the application's gem file and lock file. It does this by reading the gem file and evaluating it just like regular old Ruby code. The gem file is a Ruby DSL programming construct used specifically in the context of defining what gems to install. Evaluate will create a DSL instance in the DSL class, and it will call eval Gemfile, which as a result will call instance eval on the Gemfile contents. Instance eval will execute the Gemfile contents in the context of the DSL class. So, oh, I have pressed the wrong button. That's very fun. Let me go back. This is a first in the play button. I don't think that worked. Oh. Okay, sorry, I need to get new glasses. There we go. Woo! Technical difficulties caused by myself. We love that. Instance eval will execute the Gemfile contents in the context of the DSL class. So, for example, a common line you'll see in a Gemfile is gem name, and the version requirements. This actually calls the gem method in the DSL when you run instance eval. It'll take the name, optional version, and options as hash arguments and create dependency objects with them. It will then add the dependency objects in the dependencies list. Another method that is defined is the source method. This is usually rubygems.org at the top of a file. The DSL will add a string representing the source as the global RubyGem source. And it will throw an error if you define more than one global source. You can also have a source block if you want your gems to be installed from another source from the default. The context of this block will override the global at source with the one defined. So after the DSL objects is built with the dependencies, sources, and all the data, the toDefinition class is called, and which would accept all of these values and initialize a definition object. So we are now on part 2, which is actually installing the definition. The resolution is done by the pubgrub dependency resolver. You may have heard this in Samuel's talk earlier today. The algorithm was created by Natalie Weizenbaum originally for the Dart programming language, which is what's ported for Ruby by John Hawthorne. Pubgrub is faster than the traditional resolver by introducing something called conflict-driven cause learning. That's an interesting term, sounds very smart, but what is that? Before, when there was a version conflict, Millennial would backtrack and go up the path to find a dependency that won't introduce a conflict. However, it doesn't do a great job in remembering previous conflicts. You can hit the same failure path multiple times during dependency resolution. So pubgrub introduces a concept called traits. This is basically just a version range of a gem that either works or is not allowed and it doesn't work. And this can be used to determine something called incompatibilities. So for example, you can see here that we need to install the gem cool greater than 1.10 and gem beans at version 2.0.1 or below at the root. The initial run-through will determine you cannot install cool less than 1.1 and beans greater than 2.0.1. When going through all these dependencies, incompatibilities are tracked, so versions that we know won't work will be avoided as resolving continues. Like we found that picking a version of the cool gem we found that versions above 1.2.0 requires beans above 2.0.1. With this, we can create this incompatibility. So yes, we cannot install the Gemcool greater than 1.2.0 without installing beans of 2.1.0 or greater. And because of this, since we know that we can't install beans at 2.1.0, we can deduce and say that we cannot install the gem we can deduce and say that we cannot install the Gemcool greater than 1.2.0. You might think I just said a lot of numbers and versions at you, and yes, the algorithm is a lot more complex than this, but hopefully you get a basic idea of what compatibilities are and how they could speed up dependency resolution. The compact index is used to retrieve version information. The versions endpoint will return the versions available for all of the gems. And what you've seen before with gem install, the info endpoint will give you a more in-depth information about each gem. These files are also cached on your machine and updated if outdated by checking the version of the files. And because we're tracking conflicts, we can give better error messages to help the user to actually know what they can do to resolve these errors rather than providing more of a backtrace-like message. Once that has all been figured out, Bundler will download and install all of the resolved gems and generate a new log file with the specific versions of the gems and the dependencies you want to include per source, the platform it supports, and the Ruby and Bundler requirements. This allows all machines to install the same resolved gems if the gem file has not changed after the initial generation of the file. To use these resolved dependencies in your Ruby project, you can require the Bundler setup file. Without this, the gems that you require in your Ruby project will be based on the gems that are installed on your machine. This can be different across all machines and environments, and it essentially does this by turning on the Bundler runtime. What this means is that it will use the definition that we created during installation and loads all of the correct gem paths into the load paths environment variable. Now we know a little bit about how bundle install works. How did they work in the context of the Rails application? There are some nifty things that Rails has to manage these dependencies smoothly. The first thing I had in mind is where are all of the requires in Rails application? We saw that in gem install that you needed to require to add the gem path into load paths. And in application RB, the bundler require method, which is similar to the setup method, will require all of the gems in the application's gem file based on its groups. Yes. In the gem file, the default group is always included, and the test, staging, and production gems are included depending on the Rails and environment variable value. Rails also has something called bin stubs. So bin stubs are executables to help set up your environment to run the right version of the gem executable you want. To run a version of the gem in the gem file, you would need to run bundle exec. Without bundle exec, like just running Rails S, the executable that will be run will most likely be the most recent one on your machine, which is not necessarily the same one specified in your gem file. So that's why some people might advise you to run bin Rails instead of just Rails. The custom bin stub for Rails will include the commands of the current version of Rails that gets installed. You can generate bin stubs with the bin stubs flag or with bundle bin stub. Bundler will create a generic bin file that will make sure that you'll run the gems specified in the Gemfile. And the last thing I'll talk about is how someone can debug or work with gems in a Rails application. You can run bundle show to actually see the path of the gem that gets included. And you can run bundle open with the code editor you want. And this will open the gem code in the code editor. So you can make your edits and save. And yeah, your changes will be visible. If your application uses Spring, though, the gem will probably be cached, since Spring would preload the application so it boots up faster. So you would need to stop it in order for the Rails application to reload the files with your changes. Modifying your gems directly is very simple, but if you don't undo, it might break your code unintentionally in other areas, like other projects, and you'll be trying to figure out, like, why isn't my application working anymore? And you find out it's because of a gem that you were debugging the other day. Gem Pristine is able to reset your gems by reinstalling them to its initial state. But to avoid this from happening, I like to clone a version from GitHub and link the path of the clone in the gem file. This is especially easy if you do want to contribute to the gem later on. You can just create a branch, push your changes up, and create a pull request. So now we're a little bit more familiar with installing and working with dependencies. It's becoming clear that Bundler makes using open source libraries and other people's code so easy. You can add a line into the gem file, run bundle install, and bam, you can run someone else's code. But it's not all sunshine and rainbows. I'll be touching a bit on the somewhat evil things that can happen in the Ruby ecosystem. Firstly, it's very easy to install the wrong gem. Say you want to install Rails, but from a single key slip, you run gem install Rails. Oops. And if you haven't noticed it and run something like Rails new, it'll never gonna give you up, never gonna let you down, never gonna run around and desert you, never gonna make you cry, never gonna say goodbye, never gonna tell a lie and hurt you. Thank you. So I was too lazy to actually record my computer's audio with this and figured that singing is a better option. But I'm not joking. If you pull the Rails gem from RubyGems, you'll get this. So even though Rails is harmless fun, installing the wrong gem might have code to grab application secrets, insert backdoors, anything bad you can think could happen. Someone can write code to do it. Fortunately, RubyGems does have some basic checks to mitigate this type of attack called typo squatting by checking the name of the gems being published and checking if they're similar to other gems, popular gems, using the Levenshtein distance. And every package that gets released will go through dynamic and static analysis checks to determine if it's malicious. And it will get flagged, and if it, through further investigation, if it is, it'll probably be yanked. And yeah, gems are published by RubyGems accounts. These accounts are just like any old account that can be taken over. It's kind of like my Neopets account 10 years ago. Like, I'm still locked out, and I have like come to the acceptance that I'll never get a hold of it anymore. But getting a hold of a RubyGems account is more impactful. That person can publish a malicious version of the gem using the overtaken account. So this can be like someone taking hold of Aaron's account and publish a malicious version of Rails. Anyone that uses Rails in their applications could update to this malicious version, and then their app would be pwned. So securing an account is key. And when I mean keys, I mean multiple keys. MFA. The best way to prevent account takeover is multi-factor authentication. We currently require the most popular gem maintainers to have MFA enabled. And if you want to learn a bit more about how this policy came about, I have a talk about it from last year at RubyConf Mini. And it kind of goes through a bit about the RFC process and getting consensus among the community. We also introduced WebAuthn key support, which is more secure and convenient than the traditional one-time passwords counterpart. So you can use the Touch ID or by a security key on the UI. And on the command line interface, you'll get a custom link to authenticate using your security key. And popular accounts shouldn't be the only ones that have MFA. If you are an owner of the gem, of an open source gem, please enable MFA. It will be good for the Ruby community. Samuel from RubyGems is also working on a flow to publish gems through CI using OIDC. So this is great for securely publishing gems through something like GitHub Actions. And it's working to be released to the general public. Probably seen Samuel give a talk earlier, so if you want to chat more about that, I'm sure he'll be happy to talk about that with you. So yeah, the RubyGems team is actively working on making sure that the RubyGems ecosystem is safe and stable for everyone to use. But what does that mean for you? How do you make sure that the gems that you're installing are safe to use? Well, you never can be like 100% safe, but when using gems in a project, less is more. This isn't saying not to use gems at all, but you don't have to have 10 gems in your Gemfile that do the same thing. This will reduce the entry points in which malicious code can enter your system, and it's just easier to maintain. It might sound obvious, but I'm sure some applications install a lot of unnecessary gems. And is it a reputable gem? Are the maintainers reputable? Do the maintainers have MFA enabled? And how many users are using this gem? I would rather choose a gem called Rails with almost 500 million downloads than something called Riles, which only has 14K, which is actually kind of a lot, and maybe like 1,400 times, like maybe 14,000 times someone has been rickrolled, which is pretty funny. And yeah, that's it for now. Hopefully you can take at least one thing on how the gem installation process works, like choosing what gem to install, how gems are packaged and used, and how they are used in a Rails application. And hopefully you also take away something about selecting the right gems to use in your projects. So yeah, thank you for listening. Enjoy the rest of RubyConf. I'll be around afterwards to answer any questions or just to chat. So yeah, thank you.